Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 14 is solving logarithmic equations. So why did we do all this logarithm stuff? What are logarithms? Well, hopefully you realize now that a logarithm is the inverse of an exponential. And if I had, for example, I'm just going to explain why we do logs. I haven't said anything about it yet. Let's just say we had x plus 4 equals 7. Really simple equation. Obviously, the answer is 3. But in order to solve this, we had to do the inverse operation of addition to get x by itself. So I had to do subtraction. And when I subtract from both sides, I get my variable all by itself, and I get 3. Okay, so addition's inverse is subtraction and vice versa. Multiplication's inverse is division. If something is squared, you take the square root or whatever the nth root is. And then when we get to a function like 2 to the x equals, say, 10, well, that is an exponential function. And in order to solve this, we have to take the inverse of an exponential, which is a log. And that is why we do logarithms. Okay. All right. So now we're going to start solving equations using logs. Okay. And it says to convert the following logarithmic equations to evaluate exponential equations. To equivalent exponential equations. So if I have log base b of y, or log base b of x equals L, for instance, then that converts to b to the power of L equals x. We did this in the last lesson or two, actually. Okay, that's supposed to be an arrow. So anyway, then all you have to do is look at what is b, what is x, and what is L, and rearrange it. So when there's nothing there, it's like the square root symbol. We always assume that this is a 2, don't we? If there's nothing there. So we do the same with logarithms. Whenever there's nothing there, it's base 10. So whenever there's nothing there, we always assume that's a 10. So we're going to take our b, and that's going to become our base. So that's going to be 10 to the power of L. And L in this case is over here at 4. So it's 10 to the 4th power equals what we're taking the log of, which is x. So that equals 10,000. And obviously that is true. 10 to the 4th power is 10,000. Okay, so that's all we're doing in this exercise. So again, we have a base 10. So it's going to be 10 to the power of what's on the other side equals our x, which is the square root of 10. So it's 10 to this power equals this. It's just a nice little circle. So then it just gets quicker. Now this is base 2. So you say 2 to the power of what's over here equals 256. B to the power of L equals x. Okay, and once you get the hang of this, it is really easy. Now we got to natural log, and you're probably saying, natural log, I don't know what to do here. Natural log is just simply base e. So whenever you see the natural log, you just replace it with an e to this power over here equals x. Okay, so don't let ln scare you. It's just base e. It's Euler's number. And remember, in the calculator, Euler's number is located second divide. And it's 2.718, blah, 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 blah. Now there's also over here the natural log button. Funny that they put the E right over the natural log. So if you're ever taking a test and you're allowed to use a calculator, there's the hint right there. But the base E is natural log. So if I hit second natural log, it gives me E to the power of whatever number you're going to put up there. And there you have it. So E, natural log, is just simply base E. So this is log base 10, because there's nothing there, to the power of 3 equals what's in parentheses over here, which is our x, which is in this case x plus 2. Okay, so 10 cubed equals x plus 2. All right, that wasn't too bad, was it? All right, page 2 gives us some examples of solving for logarithmic equations. So we're going to first put them into exponential form, and then we're going to solve for them. Okay, so this is base 10. So you say 10 to the power of L, which is 0, equals our x, which in this case is 3x plus 7. So 10 to the 0 is 1, equals 3x plus 7. Subtract 7 from both sides, I get negative 6 equals 3x. Divide both sides by 3, and x equals negative 2. Okay? And then I can check that. So then if I check it, it's got to be log of 3 times negative 2 plus 7 has to equal 0. Log of 3 times negative 2 is negative 6. Plus 7 is 1. So log of 1 must equal 0. So if I go in my calculator and say log 1, enter, it is 0. So that's how you check your answers. So we're going to do problems and check them. So in this one, log base 2 of x plus 5 equals 4. My base is 2. My L is 4. And my x is now x plus 5. Okay? 2 to the 4th power is 2 times 2 is 4 times 2 is 8 times 2 is 16. 16 equals x plus 5. Subtract 5 from both sides and I get x equals 11. So then I'm going to check this. So I'm going to write log base 2 of 11 plus 5 has to equal 4. Log base 2 of 16 equals 4. Okay, so this would be 2 to the 4th equals 16 if I do it that way. Or I could have done, I guess that's the only way I could do that. Log of the big divided by log of the little, but the 4 is over here. So I could say log 16 divided by log 2. So remember that trick, log of the x divided by log of the base when we're doing change of base. So I could do change of base to solve this. Log of 16 divided by the log of 2, and that should equal 4. Okay, or I could just simply put this back into exponential and say 2 to the 4th equals 16, and yes, that is true. Okay, so this one's going to be a little bit more tricky. It's going to be trickier. We have a plus. Well, what do we do when we see an addition sign? We multiply. So we want to get this down to 1 log. So this is going to be the log of x plus 2 times x plus 5 equals 1. Okay. So base 10 is here. So that's going to be 10 to the 1st power, right? Base 10 to this power over here equals this here. And that's x plus 2 times x plus 5. Okay, this is going to give us a quadratic. So this is going to be 10 equals, and if I distribute this, some call it FOIL, x squared, outers plus 5x, inners plus 2x, 5x plus 2x is 7x, and 2 times 5 is 10. Subtract 10 from both sides, and we get x squared plus 7x equals 0. Okay, subtracted 10 from both sides, and then I just flip this over. So if I factor out an x, I get x times x plus 7 equals 0. So therefore, x equals 0 or x equals negative 7. Okay, so whenever I get an answer, I should always check it. So if I substitute 0 back in here, I'm going to get log of 0 plus 2, which is 2, plus log of 0 plus 5, which is 5. And that should equal 1. And then go to my calculator and say the log of 2 plus the log of 5 and hit enter. And it does equal 1. Okay. Then I'm going to check the other one. The log of, and now I'm plugging negative 7 in here. So negative 7 plus 2 is negative 5 plus the log of -7 plus 5 is -2, then that should equal 1. So if I go to my calculator, what's going to happen here? Log of -5, whoops, don't need a double parenthesis, log of -5 plus log of -2, and I hit enter. Okay, error, non-real answer. So you need to be careful with these because you cannot take the log of a negative. So this is what's called an extraneous solution. So my only answer here is 0. So I did this and put it in my calculator just to show you that, but we have to keep in mind that our x cannot be 0 or less than 0, I should say. Can I take the log of 0, you're wondering? Log 0 should be 1, right? Log 0 is also an error. Log of 1 is 0. Okay, so be careful with that. You cannot take the log of 0 and you cannot take the log of a negative number. Okay, exercise 1. Pause video, see if you can do this. Come back, see how you did. Okay, so number 1 says, Drew said that the equation log base 2 of the quantity x plus 1 to the 4th has to equal 8, or equals 8, can't be solved because he expanded x plus 1 to the 4th power and got x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. How did he do that? Well, there's 2 ways you can do it. You can do x plus 1 times x plus 1 and get x squared plus 2x plus 1, and then multiply that by x plus 1 and distribute and then get an answer and then do that again. Or you could simply apply Pascal's triangle, which I won't get into here, but Pascal's triangle would give you those coefficients. All right, so anyway, he realized that he can't solve the equation because he says he got this expanded and it equals 2 to the 8th, and he can't solve that. And is he correct? Well, let's take a look at this. Log base 2 of the quantity, of the quantity x plus 1 to the power of 4 equals 8. Remember your rules. This 4 can go out in front, and that will become 4 times the log base 2 of x plus 1 equals 8. Divide both sides by 4. This 4 and this 4 cancel, and we get log base 2 of x plus 1 equals 8 divided by 4, which is 2. Bring this up here, and now convert to exponential. 2 to the power of 2 equals x plus 1, okay? B to the power of L equals x. And 4 equals x plus 1. Subtract 1 from both sides, and we get x equals 3. Okay, we were able to solve it. Is he wrong? Let's check our answer first, though. Let's change colors for my check. The log base 2 of 3 plus 1, which is 4, to the 4th power has to equal 8. Well, 4 to the 4th power is 256. So you'd say 2 to the 8th equals 256. And you could say 2 times 2 times 2 times 2 times 2, or just simply go like this, 2 to the power of 8. Enter. And I've already done it. So there it is, 256, 256. So it checks. So he is not correct. It can be solved. And the answer is 3. Okay, on to the next. It says solve the equations in the exercises 2 through 4 for x. So pause the video, see if you can do these. Come back, see how you did. All right, so natural log, remember, base e to the power of. Actually, before I do that, time out. Let's do our power rule. We have a little 5 up here. It can go out in front. 5 times the natural log of 4x equals 15. Let's get that 5 out of there first and make this simpler. The 5's cancel, leaving me with the natural log of 4x equals 15 divided by 5, which is 3. Now I take e to the power of what's on the other side of the equation and set it equal to my x, which is, in this case is 4x. Okay, so e cubed equals 4x. So to solve for x, I just simply divide by 4, divide by 4. The 4's cancel, and I get x to be approximation of e to the cubed third over 4. So if I use my calculator and second natural log is e to a power, e to the third divided by 4 equals approximately 5.0214. Okay, so there's our approximate value, 5.0214. Okay, so I'm going to check it with my calculator real quickly. I got x to be 5.0214. So this is not rounded, so I'm going to store it as x so it's exact when I plug it into my calculator. Now I'm going to do my original equation and say the natural log of 4x, this is my x, remember, okay, to the power of 5 must equal 15. Okay, what did I do wrong? Not enough parentheses. Second, enter. Second, insert a parenthesis there. And put another parenthesis out here. Maybe that'll make a difference. It did. Okay, my fault. So what was this doing? It was doing the power rule, natural log of 4x to the 5th. So it was doing orders of operations, and I didn't tell it to take the natural log of everything, including that power of 5. Okay, so it's not 243, it is 15, and it does check. All right, so be careful with your parentheses in your calculator. All right, so now we have the log, no base, so that's base 10, of this equals 4. Again, we have a 2 out here. Let's get rid of that 2 first. So if I take this 2 and bring it out in front, I end up with 2 times the log of 2x plus 5. I guess I don't need 2 parentheses anymore because I got rid of that 2. Okay, so it's 2x plus 5 in parentheses equals 4. Divide both sides by 2. See how quick we get rid of that exponent? 2 steps. Bring it out in front and divide. So now we have the log of 2x plus 5 equals 4 divided by 2, which is 2. Now I'm going to convert that into an exponential. Base is 10, L is 2, x is 2x plus 5. Simplify, 100 equals 2x plus 5. Simplify more, subtract 5 from both sides. 2x equals 100 minus 5, or 95. And x is half of 95. 2 goes into 9, 4 times 2 goes into 15, 7, and there's a half. So x is 47.5. Okay, so then I go back into my calculator and check it, and I hit log, another parentheses. Actually, let me store x first. So I'm going to put 47.5 store x, enter, and then do log, double parentheses, 2x. And then if you store it for x, you're just plugging this in just as you see it. It just makes it so much easier. All right, so now I have 2x plus 5. Close the parentheses twice and hit enter, and it should be, what did I do wrong? Oh, I forgot my power. I forgot my squared right here. Okay, so that's going to be squared and then close the parentheses, and that'll equal 4, and it checks. Okay, so there you have it. All right, any questions? I hope not, because I can't hear you. Okay, hopefully you're getting the hang of this. Number 4, we have an exponent, we have base 2, just kind of look over the whole thing. Let's get rid of this power first. The 19 will go out in front, times the log of, I don't need 2 parentheses anymore, keep doing that, 5x plus 7 equals 57. Divide both sides by 19. This cancels, and I get the log, I forgot my base 2, that's base 2, of 5x plus 7 equals 3. Convert to exponential, base to the power of L equals x. 8 equals 5x plus 7. Okay, I'm going to simplify that, subtract 7 from both sides, and I will get 5x equals 1. And divide both sides by 5, and I get x equals 1/5. Okay, so if we weren't using our calculator and we wanted to know if this solution is correct, we can't get an exact, but we can tell whether or not we made a mistake and got a 0 or a negative. So you cannot take the log of a negative. So if I substitute my 1/5 in here, 5 times 1/5 is 1. 1 plus 7 is 8. 8 is not 0. 8 is not negative. And when I take it to the power of 19, it's just going to get bigger. So it's positive. So we're all good. But if I want to check in my calculator, okay, so here it is right here. I substituted in 1/5 and stored it for x. That's 0.2. So I put log of what I was given divided by the log of the base. Okay, so it's the log of 5x plus 7 to the 19 divided by the log of 2. And I got 57, so it checks. Okay, and now number 5. Solve the logarithmic equations in exercises 5 through 9 and identify any extraneous solutions. Now we really need to check to make sure if both solutions, if we get more than one, are solutions to this. So we have a log equal to something. We have 2 logs on one side of the equal sign. We don't want that. First thing we want to do is get down to one word that says log once. This minus sign tells us we're going to divide. So we take our subtraction rule or our quotient rule, and that's the log of the first term, x squared plus 7x plus 12, and divide that by x plus 4. And that gets us down to 1 log, and that equals 0. Okay. So then after I do that, I'm going to convert it into exponential. This is base 10 when there's nothing there. So it's 10 to the 0 power equals all of this, which is x squared plus 7x plus 12 divided by x plus 4. Okay, well, 10 to the 0 is 1. So 1 equals this. Okay, so I could divide this, but when I do that, I'm only going to get one solution. So instead of doing that, I can just get rid of this denominator by multiplying both sides by x plus 4. Okay. And when I do that, I get 1 times x plus 4, which is x plus 4 equals x squared plus 7x plus 2. Subtracting an x from both sides and subtracting 4 from both sides will give me x squared. 7x minus x is 6x. And 2 minus 4 is minus 2. And that's going to equal 0. Okay, hopefully you followed that. Did I do that right? Multiply both sides by x plus 4. Oh, no, that's not right. If I, let's see, just give me a sec here. Okay, my fault. This is 12, not 2. I lost a 1 there. So therefore, this is a 12. And when I subtract 4, I don't get negative 2, I get 8. Okay, this is 8. So I have 12 minus 4 is 8. All right, so I'm going to factor this. Factors of 8. That add up to 6. Well, that's 4 and 2. So my x is either going to equal negative 4 or my x is going to equal negative 2. So if I go back to the original and I take negative 4 and put it in here, I get 16. 16 minus 28. Let me just show you this. So it's going to be negative 4 squared plus 7 times negative 4 plus 12. And that's going to be 16 minus 28 plus 12. Well, 16 minus 28 is a negative 12 plus 12 is 0. Okay. All right, so that can't happen. We cannot take the log of 0. So the log of 0, that'll give us an error. And then dividing an error by something just doesn't work. So my negative 4 is extraneous. Now I'm going to check my negative 2. So that would be negative 2 squared plus 7 times negative 2 plus 12. And negative 2 squared is 4 minus 14 plus 12. Okay, 4 minus 14 is negative 10 plus 12 is negative 2. Okay. Okay. So you can't take the log of a negative. Did this become negative? 4 minus 14, negative 4, negative 10. No, that's not negative 2, it's positive 2, my fault. 4 minus 14 is negative 10, plus 12 is 2. So we're okay so far, but I need to check the denominator too. So think of that as a denominator of, or a numerator of 2, and now we need to check the denominator. And if I plug in negative 2 there, negative 2 plus 4 is 2. That's 2 over 2, which is 1. So we're okay with this one. So our answer is x minus 2. All right, sorry for that cramp, but we got it. Whoops. Number 6. Okay, let me get rid of this here. Okay, so number 6, log base 2 of 3x plus log base 2 of 4 equals 4. So both the bases are the same. We have addition, so we can get this down to 1 log base 2. And remember, when we add, it would be 3x times 4 equals 4. So the log base 2 of 12x equals 4. Okay. And then its exponential form is our b to the L equals x. 2 times 2 is 4, times 2 is 8, times 2 is 16 equals 12x. Divide both sides by 12, and x equals half of 16, 8, 6, 4/3. So x is equal to 4/3. Put 4/3 in here. 4/3 times 3 is 4. That's okay. 4/3 times 4 is 16 over 3. That's okay. The answer is 4/3. Okay. 4/3 is greater than 0. We can take the log base 2 of both of those. Therefore, it's defined. Alrighty. Actually, we didn't have to do that there. That's just log 4. Just had to check the x. Okay, exercise 7. Pause the video, see if you can do this, and then come back. So here we go. We need to be careful here. 2 ln x plus 2 minus ln x of negative x. Okay, so we have 2 ln here. We have 1 ln there. They aren't the same. We cannot do anything with this. But if we remember our rule, we can work the other direction and put this up here. So let's rewrite that as the natural log of x plus 2 squared minus the natural log of negative x equals 0. Now I have a natural log here, and I have a natural log here, and then I can do my quotient rule. And it's going to be x plus 2 squared divided by negative x. Okay, so it's a natural log of just this. I suppose I could do this, and that equals 0. Okay. So now that I've done that, I want to change this to base e. So that would be e to the 0. So I'm just going to save some time here. Well, no, I'm not. I'm going to show my work. This is new to you. The natural log is base e to the power of 0 equals this x plus 2 squared over negative x. Okay. Now e to the 0 is 1. Anything to the 0 is 1. So now we have 1 equals x plus 2 quantity squared divided by negative x. Okay, multiply both sides by negative x. Negative x times 1 is negative x. The denominator cancels here. We get x plus 2 quantity squared over on this side. So I'm going to FOIL that. X squared plus 4x plus 4. Subtract or add an x to both sides, so I get x squared plus 3x plus 4 equals 0. Okay. Did I do that right? No, it's adding. Whew. All right. Add x to both sides. 4x plus 1x is 5x. Now I want factors of 4 that add up to 5. And that's 5 times 1. One's positive, one's negative. Is that right? No, 5 plus 1. What am I doing? It's 4 and 1. Factors of C that add up to B. 4 times 1 is 4. 4 plus 1 is 5. There we go. Whew. Must be too early. So x equals negative 4 or x equals negative 1. Check these. Negative 4 plus 2 is negative 2. Uh-oh. Can't take a natural log of a negative. Extraneous. Plug in negative 1 here. A negative 1 plus 2 is 1. Plug in a negative 1 here. A negative 1 is 1. So my only solution is x equals negative 1. Okay. All right, number 8. Let's change colors. The log of x equals 2 minus the log of x. So the first thing I want to do is get all the logs on one side. So if I move this over to the other side and I add a log of x, I'm going to have the log of x plus the log of x equals 2. Okay. So when you add two things that are the same, it's the same as multiplying by 2. So that's going to be 2 log x equals 2. Divide both sides by 2. The log of x equals 1. Convert to exponential. Okay, and my base is 10. To the power of 1 equals x. So therefore x equals 10. Check it. 10's positive, 10's positive. We are all good. The answer is 10. Number 9. Let me extend this so I have more room. Okay, got all kinds of stuff going on in this one. We have a natural log over here. We have 2 natural logs over here. So the first thing I want to do is get this down to 1. So it's going to be the natural log of x plus 2 equals the natural log of 12 divided by x plus 3. Okay. No. Okay, that's just going to get really messy fast. Once we get to this point, I realize that's probably not the best way to do this. So let's change this. So what can we do? Let's move this natural log of x plus 3 over to the other side so we have an addition on the left. So it's going to be the natural log of x plus 2. Adding this to the other side will give us plus the natural log of x plus 3 is going to equal the natural log of 12. So what am I doing here? I'm trying to get all of my variables. Okay, x's all on one side. So there's your hint there when you have multiple things. Here's a natural log of 12. Get the constant on one side, get the x's on the other, and it will run a lot smoother. So then I have the natural log of, and this is plus, so it's a product of x plus 2 times x plus 3. And that's going to be the equal the natural log of 12. Okay, so if I'm taking the natural log of something and I take the natural log on the other side, then what we're taking the natural log of obviously has to be equal. So x plus 2 times x plus 3 has to equal 12. So the natural logs cancel here. And I get x plus 2 times x plus 3 equals 12. And I'm just going to factor that. And it's going to be x, not factor, but distribute and FOIL. X squared plus 5x plus 6 equals 12. Subtract 12 from both sides and we get x squared plus 5x minus 6 equals 0. I want factors of -6 that add up to 0. So I know that one's positive and one is negative. And 6 times 1 is 6. And a positive 6 and a -1 will add up to 5. So it's x plus 6 or x minus 1. And therefore x equals -6 or x equals 1 using my zero product property. Okay, so then I check it. I put -6 in here. -6 plus 2. Uh-oh, that's -4. I can't take the natural log of a negative. The -6 does not work. It is extraneous. Plug in 1. 1 plus 2 is 3. We are good. That's a constant. We're already okay. Plug in 1 here. 1 plus 3 is 4. My answer is x plus 1. Okay. Okay, this page brings us to the end of lesson 14. Go to your problem set.